Full Wi-Fi.
What's the name of this lesson?
Just other interesting derivatives and related stuff.
You know what?
Can you review lemon one day? We will review a lot of data. Okay, so today I want you to see how many things derivative and integration. I'm going to review our integration derivative and how much you know. So first thing is I want you to take a derivative. I want you to spend 30 seconds take a derivative of this one. E to the negative 2x cosine square of x. Has nothing to do with natural log derivative. It has everything to do with cosine square of x, yeah. So I want to find dy dx. So I'm going to kind of give you a heads up, which is how to take a derivative e to the x. That's probably the hardest thing you ever learned, was derivative e to the x. Are you serious? It's e to the x.
Yes.
My goodness.
And then typically out there.
Okay, hopefully you know how to do this. You don't know this? Yeah, I never test you this because there was a one in the last section before the volumes. So I never did test you this. So yeah, derivative e to the x equal to e to the x. Derivative e to the u is eu du dx.
What? Buddy. What do you say? I said he said that
M for what?
Oh, I smelled that. How do you say that? The chain rule. Chain rule made me do it. What chain rule?
Okay, so if I take a derivative of this, right? Derek, what are you doing with your phone?
This isn't my phone, this is wrong. It was showing me a video.
Okay, so if I take a dy dx, there was what kind of rule is involved here? Product, good. What else? Chain rule. So there's a product and chain. So if I'm taking derivative of just this part, e to the negative 2x, you should get what? Negative 2 e to the negative 2x times cosine square of x plus, right, e to the negative 2x and derivative of cosine square of x. What's derivative of cosine square of x? Negative 2 sine of x and the cosine of x. It turns out this here is also known as a double angle identity. So sine of 2x is equal to 2 sine of x cosine of x. So that's equal to negative 2 e to the negative 2x cosine square of x minus e to the negative 2x times sine of 2x. So that is the final answer. You can even factor out e to the negative 2x out if you want to, but you don't have to. So you can even do this. If you really want to, it's going to be negative 2 cosine square of x minus sine of 2x. So, but that's okay. If you got to this part, it's good. If you got to this part, even better. If you got to this part, even better than before. But I'm okay with the first line. Okay, that's that. Okay, so that's just some brief stuff that you're supposed to know. Another thing you're supposed to know is how to take integration of something like this. E to the x of 1 plus e to the x dx. Natural log of 9, natural log of 9, natural log of 3 or something like that. Okay, you should know how to take integration of this. So let me review a couple of skills that you're supposed to know. One is, well, first two, you should need to know how to do this. Second, do you know how to take a derivative of a natural log of x? What is it?
1 over.
1 over x, good. D to the dx of natural log of u, it's going to be du over u, right? So u prime over u. Now, what happened if it's an integration of e to the x? That's just e to the x plus c. E to the u, the only thing difference e to the u plus c, but however, you had to pay attention to the du dx part. So this one's dx, this is du. Because you had to convert that du into dx. Then one last thing, did you know how to do integration of 1 over x?
Yes.
Integration du over u is natural log of u plus c. So it requires a couple skills from, it requires essentially this skills here, right here. And the skills right here require kind of both, which is you have the involvement derivative of e to the x. And also knowing that there is a relationships between u and du. What's the relationship? The denominator and numerator has relationship of one derivative away. Okay, one derivative away. So kind of reminder of this. Let's just say if we have 2x over 1 plus x squared, right? Do you see that they are one derivative away? See derivative of x squared equal to 2x. Then that's a automatically natural log integrations. So if you have one derivative away between numerator and denominator, that relationship is always natural log. It's always natural log. So in this case, this would be natural log of 1 plus x squared because you're going to u equal to 1 plus x squared, du is equal to 2x dx. And the 2x would cancel out. So this is the problem. So I'm going to show you this. And you're going to do that one there. So u equal to 1 plus x squared, du is equal to 2x dx. And remember, solve for dx. Dx equal to du over 2x. And that's going to be 2x over u times du over 2x. And that would cancel out. That would be equal to natural log of 1 plus x squared plus c. So that is the integration because there's a one difference apart. So how do I do this questions here? The same exact thing. What?
5 over 2, ln? ln of 5 over 2.
Yeah, something like that. So u equal to 1 plus e to the x. You see that derivative? It has that e to the x part. And you know that is integration. So that's why I said u equal to the bottom. And du over e to the x equal to dx. So that's going to be a e to the x over u times du over e to the x. This is simplified down to du over u. Now, natural log of 9, I'm going to tell you this. 1 plus natural log e to the natural log of 9. And 1 plus e to the natural log of 3. What will happen with e and natural log? Cancel. That's equal to 10. That's equal to 4, right? So that is going to be u. And this is 4 to 10. So that's going to be natural log of 10 minus natural log of 4. Because this is equal to natural log of u between 10 to 4. And then it's subtracting does not because it becomes natural log of 6. It's actually natural log of 10 over 4. So it's equal to natural log of 5 over 2. And that's the... What happened there? Oh, good job. Good job. And I'm happy for you. Joanne is like I said, like I think she had more balls than a lot of guys in this classroom because she actually didn't take pre-calc and she actually have horrible algebra 2 and then she's taking calculus after the third night week. So yeah, I think she have a lot more cojones. I say in Spanish. Yes. I have a good. I know how to curse in all Spanish. I swear. That's like first language I learned in America. When I was in ESOL class, I learned more Hispanic curse words. I came and curse in English. I curse in Spanish. Okay, so that's really good. So once you understand this, so this is kind of review of all the things combination. So we got some homework about that, but we also have new things that you have to learn today. What is the new thing you have to learn today? One is this rule, which is you don't use it. You don't even have to write down, but I just have to show you. Is d to the dx of a to the u is equal to natural log of a, parenthesis a to the u and du dx. Yeah, so you don't memorize this. Trust me. The next one's worse. The next one is going to be log of a to the u is equal to 1 over ln of a times 1 over u times du dx. So I will just cross it out directly. I won't even use it. Instead, I'm going to use something else to help you. Is learning things through associations. If you learn things with association, then you can understand things a lot better. So here's learn things through association. If you ever have a to the x, so for example, a to the x here, so y equal to a to the x, use log differentiations. And that's how they get this formula. How about second thing? Use changing base equation. Changing base equation. And let me review what is changing base equation, which is log of b to the x equal to natural log of x over natural log of b. This is a very useful tools. Instead of memorizing this crap, you can knowing this much easier to understand because that's just a changing base equation from algebra 2. Then you say, hey, what do I mean by that? Hey, how do I take a derivative of this? How do I take a derivative? Okay, so find y prime. What are you supposed to do? No, it does not become 6x. No, you cannot do that.
Oh, no, it's minus 1.
No.
Oh, shit. We're in a deep shit. Let me change all you guys' color. Let me change it to a red.
Thank you.
David just download from a blue to a red, like in an instant. Okay, so use logarithm integration derivative so that you can do a natural log of y equal to natural log of 2 to the 3x. We've done this before.
Oh, yeah.
With y equal to x to the cosine square of x. This is on your test. We did the exact same thing as this one. So what happened is, nice thing about natural log is 3x can be placed in the front.
Oh, Michelle, we didn't have this week.
What?
We didn't have this week.
Hold on. Okay, so now, are we okay so far? Okay, so remember in math, you don't have to understand a lot of things. You just have to understand where the parentheses lie. Where the parentheses lie? Where's the parentheses located at? Okay, so you're gonna see there's a parenthesis right here. There's a parenthesis here, parenthesis here. The nice thing about this 3 parentheses, you can change the order. So if I change the order, what am I gonna get? Well, I can put all the constant together and just do like this. Why do I do that? Because I can take a derivative now. to the this. If I take a derivative of this, we already know that's y prime over y. What's the derivative of 3 natural log of 2x? It's not 0.
dy over dx.
No.
Is that just a number?
Yes.
It is. I don't remember what the derivative of just numbers. It's not.
Well, you think about it. If I were to take a derivative of 3x squared, right? What essentially happened is you can take a 3 outside and just focus on the x squared. And that's equal to 3 times 2x. And that's equal to 6x. So constant has nothing to do with derivative. Constant can always take all the way out. And this is a very, very powerful rule. This is called constant multiple rule. If you ever take a derivative of anything k to the f of x, it's always k derivative of f of x. That's just always true. If you can see that, your math path is a whole lot easier. Now, what happened is you just take a derivative of x, which is 1, which is y prime equal to 3 ln of 2 times 2 to the 3x. And that's your final answer.
Wait, are we doing not to, I was gonna ask you any questions, but I guess. I mean, like, don't we have to though? What about product rule?
Okay, so some people say it's product rule. Okay, let's show you product rule. 3x times ln of 2. Why would you want to do product rule? I'm going to show you, you don't do product rule, but I'm going to do it anyway. What's the derivative of 3x? It's 3, right? ln of 2. Does that make sense? Plus 3x. What's the derivative of ln of 2? What did you get? Sam. So why would you want to do product rule when you don't have to? You can do a constant multiple rule just by moving the constant to the front. That's what I'm saying, yes.
It's annoying. I remember in my life.
I moved the y to the other side.
What was y?
Y equal to 2 to the 3x. Which is, that's what you screwed up on the last test. You didn't come back to redo it. So that's a part you need to redo. That integral test.
I'm sorry, what?
So that's the only one that's holding your grade right now. So, okay, so questions? No, it's not that bad. You already learned this already. You just have to recognize what's constant.
Oh, the y is. Oh.
What?
Oh.
I don't know.
Yeah, I moved the y to the other side. Y is equal to 2 to the 3x.
That was my struggle. Well, I don't think we did that in class.
We did that on the last test.
No,
Integral
I know.
test.
Moving the lines.
We did it with this question. We did this is a test question from the last test for the integral test.
No, I know.
Oh, I remember that.
I'm saying that I don't think we really got it right. You will?
He didn't mean they got it right. Okay, so the next thing is, hey, do you know how to take a derivative of this? So log of 6 of square root of 3 minus 2x. So you say, holy crap, it's the first time I deal with log. But log is nothing scary. Log is just natural log of different version, right? So I'm not going to do calculus at all. I'm just going to do algebra. What is the first thing with the square root? Base in 6. Can I change this to a 3 minus 2x to the 1/2 power?
Yeah.
Can I place it in the front?
Oh, that's a 6, not
Can I change log to 6 of something equal to something else?
Maybe. That enthusiastic tone.
What does this rule tell you? Log of base b of x is equal to natural log of x over natural log of b.
ln of 3 minus 2x over
put a 1 there. You go. Good job.
Basil was like, I got this.
That's the answer.
No, it's not an answer. This is just doing this just changing this to an algebra base. So I'm gonna show you that math is actually not so hard if you recognize what a parenthesis is and where is the constant.
Wait a second.
So- So no, pay attention here. What is that? That is just a constant. So can I take it out completely? Is equal to 1 over 2 ln of 6 times ln of 3 minus 2x. Can I do that?
Yeah.
Now remember, the constant has nothing to do with derivative. Constant can take out completely. Does that make sense?
Yeah.
So can I do this? Y prime equal to 1 over 2 ln of 6. The constant, just take it out completely. I just have to focus on derivative of this things right here, which is really easy. Negative 2 over 3 minus 2x. So I cancel out negative 1 over natural log of 6 times 3 minus 2x. This is not x, this is a 2. This is a 2, and they just cancel out with the 2 on the bottom. So the 2 and 2 cancel out because negative 1 over natural log of 6, 3 minus 2x.
It should be a big piece like around.
Around what?
But like should be a parentheses around like 6 times 3 minus 2.
You can have parentheses, but you don't need to write it down. Like you don't need to write down 2 times x plus 2. You don't need to do that. It's not necessary. It's a constant, so it doesn't matter need a parenthesis there. But you need a parenthesis on the second part. Yes.
I'm curious, just why could you flip flop between log and natural log and matter?
Wait, what's your question again?
Like, so we go from just log base 6, then we're using natural log. I don't understand, like, it's just no, I don't understand.
Why don't we go from log to ln?
Because we know how to take a derivative of ln, we don't know how to take a derivative of log.
So, but log, I don't get.
Yeah, that's called changing base equation. And so there's a way to changing logarithm to natural log. It's using this formula right here. This formula here is natural log b of x equal to natural log of x over natural log of b.
Well, isn't it also?
Oh my god, seriously? Yeah.
Like, just change natural log to log, you wouldn't also be correct statement? No.
Changing natural log to log.
Yeah, so if it was log of x over log of b, would that be incorrect?
No, that would be the same. Yeah, there's another way. It's called log of x over log of b. But I don't want it to do log. You can type in a calculator. Actually, pretty interesting. If you do natural log of 5 divided by natural log of 3, as opposed to log 5 over log 3, you're going to get the same answer.
It's like percentage litigants, like.
Yeah, they're the same idea. They just different base. But they still exponential function. They still work out. All right, so yeah, homework is already posted. You can start early. The only thing I would tell you is this, guys. On your homework, you gotta pay attention to this. What happens if you have e to the negative 2 natural log of 3? Can e and natural log cancel?
No. Why not?
No, you cannot.
No.
So what you can do is you can do this. Now you can cancel to 3 to the negative 2 is equal to 1 over 9. So those are the things that you got to be able to recognize. If you recognize a parentheses, you recognize math. If you don't recognize a parentheses, you don't recognize math.
Go back to the answer from the writing, like the question you know. Why is the negative 1 on?
Because 2 and 2 cancel out.